Well, welcome to Math 10C. Today we're going to look at our factor tree and different types of factoring. To get started, whenever we factor, or what is factoring? Factoring is breaking down our polynomials into smaller parts, into its factors. And we're going to do that with several different processes, because when we're told to factor, there means a number of different things. First of all, whenever you're told to factor, it means that you're going to try to remove the greatest common factor. Now, after you've factored out a greatest common factor, you're going to move forward and see how many terms the polynomial's got. If it's got 2 terms, you're going to use one method of factoring. If it's got 3, there's a couple different things that you can do. And if it's got 4 terms, there's a different method of factoring. Today, as you can see, we're going to look at the sum product method. This is where we're going to look at factoring a polynomial, trinomial, such like x squared plus 7x plus 12, and we're going to learn how to break it into its 2 parts, x plus something and x plus something or minus something. And what we're going to do is use what we call the sum product method, where we have to find 2 numbers that multiply together to give us 12, and those same 2 numbers have to add up to 7. And what we do is we're going to place them there, and that's how we're going to factor. So let's get into it. First of all, let's review. First thing we did last week was look at factoring out a greatest common factor. And whenever you're asked to factor an expression, you must first look and see if there's any common factors that belong to all the terms. If there is, you can divide each term by the greatest common factor and then rewrite the expression as the product of the greatest common factor and the quotient. In our first case, 6m plus 9n. When you look at this, you can see that you can divide 3 into both of these terms, so we can express 6m plus 9n as 3 times 2m plus 3n. In the second one, be careful here, 6y plus 1y, I can add those 2 together to get 7y, and I won't factor that one at all. In C, this time when I look at dividing something into both terms, I can divide a 3 into both terms, but I can also divide an a into both terms. And this would leave me with 3a times the quotient, which would be 3b minus 4c. In D, we're going to look at dividing something into all 3 terms. That would be the biggest thing we could. 5 goes into all 3 terms, and I could divide an x out of all 3 terms. So this will equal 5x times 15 divided by 5 is 3. X divided by x is x squared divided by x is x. Minus 2y, and then minus 4z. And the last one, E. Divide 7 into both of these. I could divide an a squared into both of these, and I could divide a b squared into both of those. So my biggest or greatest common factor is 7a squared b squared. So there I have 7a squared b squared times the quotient, which would be 2 plus 3a minus 5b. Here we're going to look at factoring those trinomials. To factor a trinomial like x squared plus 7x plus 12, you have to find 2 numbers that multiply together to give you the last term of 12, and yet add together to give you the middle term of positive 7. And then you're going to express the trinomial as the product of 2 binomials. Notice that 4 times 3 is equal to 12, and 4 plus 3 is equal to 7. So what we're going to say is that first number, our x squared, can only be found if I go x times x. Then plus 12 and plus 7 is going to be, one's got to be plus 4, and the other one's got to be plus 3. And you can check it by foiling it and seeing if you get x squared plus 7x plus 12 back. And if you did, you know you've got the correct solution. In our second one, we need 2 numbers and multiply together to give you positive 4, and yet add up to positive 5. And the only thing that's going to work there, it'd be 4 and 1 is 4, and 4 plus 1 would be 5. So 1 is going to be x plus 4, and 1 is going to be x plus 1. And it doesn't matter which order. In the third one, we have x and x being x squared, and then two numbers that multiply together to give me 3 and add up to 4 would be 3 times 1 and 3 plus 1. So we could use 3 times 1 and 3 plus 1 gives us x plus 3 times x plus 1. Now in this next one, we've got something a little bit different. Notice that these two numbers have to multiply together to give us negative 30, and yet they're going to add together to give us negative 1. Well, there's a number of clues here, even though it looks much harder. First of all, since it's got a product of negative 30, that means that the first thing it's telling me is that one of the numbers must be positive and one of them must be negative. The second clue is that the two numbers have to be one number apart because they're adding up to 1. And it's a negative 1, which tells me something else, and that is that the negative 1 is going to be 1 bigger than the positive 1. So now that I've got all of those clues, can you see what number it is? I hope you can. I hope you can see that 6 times 5 is 30, and that the negative 6 times a positive 5 will also add up to negative 1. So one of these brackets I'm going to put in x minus 6, and the other one I'm going to put x plus 5. In the next one, it starts with a 4x squared minus 3x plus 48. So here's a clue. Factor out the greatest common factor first. When you do that, you can look and see, well, I can divide 4 into all of those terms. So now I've got 4 times x squared minus 8x plus 12. Now you're going to look at just the x squared minus 8x plus 12 and ask, are there two numbers that I can find that multiply together to give me positive 12 and yet add up to negative 8? Well, hopefully you can see that they're going to have to be two negative numbers. Therefore, when we write this as the product of two binomials, I can say, well, what can I get? I hope you can see that one's going to be minus 6 and one's going to be minus 2. In the last one, if I divide both of these by 3 and an x, I can say I'm going to get 3x times the quotient of x squared plus 5x minus 6. Now I can further factor this into two binomials. 3x stays there. Two numbers that multiply together to give me negative 6 and add up to positive 5. This is a little bit more difficult. Be careful there. That would probably be, remember that these two numbers are going to multiply together to give me negative 6. One of them is going to be positive, one's going to be negative, and they have to be 5 numbers apart. Sounds impossible, but the only number that can be is 6 times 1. And if it's a positive 6 times a negative 1, we're going to find our two solutions. If you multiplied that back out, you'd see what it was. There we go. That's it. Your assignment is to do page 166, numbers 11 to 21.